This is Catherine Schmur at Chattanooga State Community College. This is video 4 of Lines in Space. In this video, we'll talk about how to find the distance from a point to a line in 3 dimensions. The distance from a point to a line in space can be defined as the length of the line segment that is between the point and the line and that is perpendicular to the line. Now I have a picture to illustrate this. So I have a point S out in space, and I have a line that has direction vector V and point P on the line. Now what I do is I make a vector starting at point P on the line and going out to point S in space, and the angle between the line and that vector is theta. Then what I do is from point S in space, I drop down a line perpendicular to the given line in space with direction vector V and point P. And that creates a right triangle with the line as one side of the triangle, the vector PS as the hypotenuse of the right triangle, and then the third side between point S and the line is going to have length magnitude of PS times sine theta, just using right triangle trigonometry. So we can see that the shortest distance from the point S to the line through P parallel to V is D equals magnitude of PS sine theta. Now we won't usually be given an angle, and so what we want to do is try to come up with a formula for distance that does not include an angle. So we think back to our section on cross products, and I hope you remember that the magnitude of PS crossed with V equals the magnitude of PS times the magnitude of V times sine of theta. So solving this for what we decided D was, the distance, so solving for magnitude of PS sine theta, we get that the shortest distance from S to the line that is through P and parallel to V is D equals magnitude of PS cross V divided by magnitude of V. This is the formula that will be on your formula sheet for the test. So let's go through a problem, and we want to find the distance from the point 1, 2, negative 2 to the line x equals 1 plus 2t, y equals 5, z equals 3 plus 4t. Our first step is to identify our points, P and S, and find the vector PS. Now remember, P is a point on your line and S is the given point. So to find a point on the line, P, I'm just going to let t equal 0. So let my parameter equal 0. So I have x equals 1, y equals 5, z equals 3. So that's going to be my point P on the line. Now the other point S was given to me, 1, 2, negative 2. So there's my point S. Now the other information I can get from the line is the direction vector, and we'll need that a little later because that's the V in the formula. So remember, direction vector is from the numbers attached to t. So I have, with the x component, I have a 2. Y component has no t, so that will be a 0, and the z component has a 4 attached to the t. So my direction vector V is 2, 0, 4. So we'll just kind of set that aside and use it later. Right now, we want to find vector PS, and so I do S minus P, components of S minus components of P. So I get 1 minus 1, 2 minus 5, and negative 2 minus 3. simplifying that gives me the vector 0, -3, -5. So I have vector PS. Now remember, in the formula, I want to cross this with vector V. So my second step is to calculate the cross product of PS and V. PS cross V equals the determinant of matrix IJK 0, -3, -5, 2, 0, 4. So remember, I'm putting vector PS in the second row and vector V in the third row. Now I'll expand. That's going to be -12i minus 10j plus 6k. Now my third step is to use the length formula to find the magnitude of PS cross V and the magnitude of V. So the magnitude of PS crossed with V is equal to the square root of 144 plus 100 plus 36. So remember, I'm squaring each component of PS cross V and putting it into a matrix. Putting it under a square root. This gives me the square root of 280. Now the magnitude of V is square root of 4 plus 0 plus 16, and that gives me the square root of 20. And now in the formula, I know that my last step is to divide the magnitude of PS cross V by the magnitude of V in order to find the distance from point S to the line. So D equals the square root of 280 over the square root of 20, which is the square root of 14. So that's the distance from the point to the line. So to use this formula, always follow these steps. Find your points, find your vector PS, cross that with your direction vector V, find the magnitude of the cross product and the magnitude of your direction vector, and then divide.